Good morning, students. In this lecture, we are going to discuss about memory. Here, we are having now the basic memory cell. So, basic memory cell means we can store a single memory cell where we can store either 0 or 1. So, here we are having a storage or not. So, that is, we are having a storage or not. That is, we are going to see. So, if stored value, then we are getting value 1. If there is no storage, then that is 0. So, 1 and 0, either 1 or 0, we can store it. Then we can retrieve, right? So, we can store as well as we can retrieve that information, right? These cells can be grouped together as called word, right? So, here we are having now the cells around 8 cells. We are having that 8-bit information, 8-bit binary information, 8-bit binary information we can have. All right, so here we are having now basic memory cell. So basic memory cell is nothing but a memory cell stored a single bit of information. So this is a memory cell we are storing single bit. So in that case, we are having two types of memory cell, right? So that is static RAM and dynamic RAM. The static RAM is a latch like a flip flop, hold the bit, right? So hold the bit, retaining it as long as the power is supplied. So if you are having now the RAM is a memory where we are storing that information. This information is retained until the power supply is retained. If power off, then the information will goes off, right? Then here we are storing, then while power off, then we can store it and we can retrieve it. Then that value will be retained on that. So we can store either 0 or 1, right? Then we can store as well as retrieve. So like we are having that array of memory, then we are having that information. So total memory is we are having now a large volume of the memory cell is called the total memory. Now the static RAM is here. The static RAM is designed through a latch. Latch means here we are having now as like the SR flip flop or otherwise we are having some other devices. Then that one can hold one bit of information. So like that array of information. Next one is dynamic RAM. The dynamic RAM is designed through a capacitor. So the capacitor is having a capacity to store voltage. So if you are applying that 1 volt voltage, right, then that voltage is retained in that charge, the form of charge, right? This charge actually here, if you are having time elapsed, then it will be discharged. So you have to dynamically, you have to repress this circuit, whatever you are saying, right? Storage or not storage, right? Stored, then the value is 1. There is no storage, the value is 0. So this also is stored 1 bit of information. So if you are applying that 1 volt voltage, then it will store, then we are having that value 1. Then whenever we are retrieving, the storage is showing now that value 1. Then if you are having 0, then there is no storage, then it will show that one 0, right? But the charge is going to be decay with respect to time. So this is the thing. So periodically we have to store whatever the data, then you have to repress the data. That is called dynamic RAM, right? So the DRAM is a capacity to store 1 bit of information as an electrical charge. The charge leak over time, the charge leak over time, then requires the memory to be periodically repressed. This is the dynamic RAM. So dynamically we have to restore that information, then only we can retain its value, right? So this is periodic restore is like that. The DRAM is somewhat less cost as compared with SRAM, right? So this is SRAM, this is DRAM. So two types of memory cell, the DRAM and SRAM. Then we have to give some. So here RAM means random access memory. It here we are having now that one RAM characterized by the ability to read and write information to any memory location with approximately the same access time. So here we are having now that we are having that cell. So array of cells are there. Then we can store that information and we can retrieve that information. then the access time is wherever that location, right? The location means this is one row, then another row, like we are having now that array of memory. Then here we have to give one particular address. That address is going to be enabled. Then this value is going to be stored, and we can retrieve. We can retrieve. Right. Now it is volatile. RAM memory is volatile, meaning that the data is lost when the power is removed. Right. RAM is crucial for running programs and store the data actively being used by the computer. So here we are having the RAM memory is while power is on, then we are using now that store and retrieve. Right, the power is off, then the RAM memory content is going to be erased. Right. Now next one is memory decoding. Memory decoding means actually we are having array of memory. I told you that one. If you are having that 8-bit data, right? So 8-bit data is one array. 8-bit memory cell is one array, like we are having a number of arrays, right? Then here each array is required an address. So here we are having address for each row is having that address, right? Now here we have to in that address bus we have to give the address value. We have to give the address value, then that corresponding row is enabled. Then you want to store the data, we have to give the write cycle, then it will store the information, right? So this is a bus. In that bus we are having 8-bit information is there. So this 8-bit information is as like this one, right? This information is going to be stored on that particular row, right? Whatever the row is enabled through the address. So in that address we are having now enabled, then that particular location is going to be store the data. Then other end is we are having read the data. So we can either read mode or write mode. Then we can have whether we want to store it will go for write mode. Then you want to retrieve it will go for read mode. So read write mode is there. Then here you have to select the read mode if you want to read. So select the write mode. Then you want to write that content into the storage. Right. Now how is? So to access a specific memory location, this is important. A specific memory location, right? Like question within a large RAM array, I told array. The address line is used to select the appropriate memory row, right? Address line is lines are used to select the appropriate. So this is the address line. Sorry, this is the address line to enable, right? So then we are having now this is the data bus we are sending now the data. A decoder circuit takes the binary address. Binary address is input and activate the specific output line, right? So this is a address line. So in that address we have to give the, so here this is a 16-bit address means, then here we are having the 16-bit information, right? So here we are having that address. So this is we are having now one particular address of 16-bit. The 16-bit address is going to be give the address line. Then the corresponding row is selected. It's enabled. Then we are giving the data to the line. It's a common for all row. Right now you are giving that information. Now it is enabled with that one. Then that information is going to store the particular row only. All others are unchanged, right? Then we are retrieving that one. Then you have to select the corresponding address. You have to give the address line address. Then it is enabled. Then whatever the information is stored here, that information is going to come now as a in the data line where we can retrieve the data. Right. A decoder circuit takes the binary address as input and activate a specific output line, the corresponding to the selected memory word. So memory word. So this is one word. Either it may be 8-bit or 16-bit or 32-bit, right? Currently we are having 64-bit address, right? So we are having a 64-bit data. Your computer is having 64-bit data, 32-bit and so if here we are having now 64-bit data. So this is one line, right? Now here memory, if you are having now that 1K memory, 1K memory means here we record 2 power 10. So we are having 10 address line is required. So 10 address line is required. So that 1024 location. So the 1024 is represented by 2 power 10. So here we are having that 10 address line is we required 10 bits. So that is here 4, 4 and another one 2. So 10-bit address line is required is a starting. Then at the end is we are having 10 ones. In between we are having the binary number. Then this number is address line where we are having 1024 8-bit data memory. We can get it now, right? Allow the processor to read the data from and write the data into the correct location. To read data and write data to the correct location. To the correct locations now, right? Here I told you that one static memory and dynamic memory, right? So they may ask that what's the difference between static memory and dynamic memory? Static versus dynamic, right? So SRAM is static RAM. Static RAM uses flip-flops for the data storage. It is faster, it requires less power to maintain the data, but more expensive and has lower storage density per chip. Lower storage density per chip means the chip itself, if you are having now sizes, memory size is very less for the chip. If you are having dynamic RAM for the same size, it store more information. This is right because of the SRAM is having that all flip-flops. Here we are having a capacitor only. The dynamic RAM, we are having a capacitor, a small capacitor. So we can, within that area, we can have more number of cells. Here in that SRAM, in that same area, we can have now less cell. The cell size is big, right? So SRAM. So that is here. So you have to write that one as we are using flip-flop for data storage, and it is faster and require less power. So we want to have less power to maintain the data. No repress is required. Periodically is repressing is required for DRAM, but the SRAM there is no refreshment is required. But it is more expensive and has low power storage density. The important point. Low power storage density means within that area we are having now the size of that memory is small as compared with DRAM, right? DRAM is use capacitor. So here you are using flip-flop. Here you are using capacitor. The capacitor for storage information, right? Which require periodic refreshing. So the dynamic is periodically repressing due to charge leakage. So charge is continuously leaked. Then we have to rewrite the once again the data. So this periodically it will do now, right? It is slower than SRAM. So speed is somewhat less than the dynamic RAM, right? Consume less power and offer higher storage density at low cost. So higher storage density at low cost. Right. Then one more memory called cache memory. Cache memory is actually your processor and the near to that one is cache memory and then RAM. So cache memory is a small size, then it is faster. Cache memory is small size, the costly and also faster. So whatever the data you want to execute in the processor, then the data if in cache, it will store and retrieve fastly as compared with RAM. So whatever the data, current data is required, the data will come to cache memory. Then through the cache memory, the processor will take that information and read write information is fastly. So that is which is very small. So cache memory is very small and fast memory is the speed of the access of frequently used data. So frequently used data is placed on cache memory. Okay, often utilizes SRAM. So SRAM we are getting now the SRAM, yeah, the static RAM we are getting now the data to cache that cache memory we can, right? Main system memory RAM typically uses DRAM. So that memory is DRAM we are using because of the high density and low power cost, right? Okay. Next point is not taken. Right. Now the basic memory cell, SRAM memory, right? So the SRAM memory cell is this one, right? So they may ask basic memory cell, basic memory cell or SRAM, static RAM, right? In that static RAM, I told you that one latch is, it will store one bit information, either 0 or 1, right? So here, in that one, we are having that cell typically consists of 6 transistor, 60 RAM cell, right? Arranged in the cross-coupled configuration. So, in a cross-coupled configuration to store one bit data. So, this is a cross-coupled, right? So, here we are having now, this is one direction, this is the opposite directions, right? The configuration creates two inverter. So, this is one inverter, then this inverter in this direction, and this inverter in this directions. We are having two inverter each connected to other, ensuring that one inverter is always on state, the while other is off state. Thus maintain the stored bit, right? So here, if it is on, this is off, right? Then here the orientation is here in this direction, right? If it is on, then the orientation is in this side, right? So that depends on orientation, it is either stored 1 or 0. So at a time, one inverter is on, then another inverter is off, so it will retain its value in that cell, right? So one on, one off. Then here it will have the maintain the storage bit. One on, one and off means then here there is no circulation, so it will be retain its value. Then whenever you want to read the data, then we have to give now the, when that word line is on, the word line is on, then we are getting now the bit line, bit is we are taking now. So this is if you are storing the bit, then here it is 1, right? Then the inverter is 0. If you are storing the bit is 0, the inverter line is, the bar line is 1, right? So we are storing that 1 1 0, we can store it, right? The cross coupled inverter, that is the heart of the SRAM, right? So cross coupled inverter is the heart of the SRAM, cross coupled inverter, right? You can stop 4 transistor, 2 NMOS and 2 PMOS arranged in the way that they form two cross coupled inverter. So that is the diagram, right? This inverter maintain a stable logic state, either 0 or 1, by holding one transistor is on, then one is off. So it is holding. Right, for storing 0, the one transistor on, right? For storing 1, it another transistor on, then another one off. So here we are having two additional transistor for act as a switch. So that one is here. These two are act as a switch, right? So this is a storage. Then whenever you want to access that one, then this is a switch line. If you are giving this NMOS, this mass is going to be on, then that information is going to placed on the line. If it is off, then this is only isolated and it is having storing its data, right? While on, then a small amount of power only is used for getting the data, right? So that is the SRAM, right? Okay, act as a switch, right? The other both end is act as a switch. So that is NMOS, two additional NMOS act, right? So NMOS act is here we are applying that word line, right? Connecting the storage node of the inverter to the pit lines during the read and write operation. So read and write operation only that the pit line is going to be enabled. So the pit line, word line is going to be enabled. The corresponding pit value is in the pit lines. Pit value is 1. If you are storing 1, 1 is in the pit line. The 0 is in the inverter. Right? The bar line. If you store 0, here the bar is 1. Right. So bit line is bar storing reading. So word line, bit line, we are having now the bar storing. Like that, this cell is, we are having array of cells. So if you are having 8-bit information, the same cell is repeated for 8 times. Then we are having word line. and each one is having bit line. So the bit line is for we are having now the read write data. So while writing, then we are sending now, then while reading, we are get the data in the bit lines, right? So the bit lines are two bit lines, the B and B bar. We are having bit line bar. Each one is having B and B bar. Which one is we want to get, then we can get it, right? So the word line is activated and turning on the access transistor. So if the transistor is access, then the bit line are wire line is here we are making active. Bit lines are pre-charged to a high voltage. So we are applying that voltage. A small current flow through the axis of cell. So this won't leak the current, right? Causing a slight voltage drop. One of the bit line during the storage. So it will be retained. So we are having 10 times or more, 100 times we can read the data, then the storage will be retained, right? So that is here. A sensor amplifier detect this voltage difference and amplify it in the fully. So here we are having one amplifier is there, right? If you are having the voltage level is actually we are having now 5 voltage is 1, then ground is 5 voltage is 1, then ground is here we are having now 0 voltage is ground, right? Now the range is here 0 voltage is ground, 0 voltage is ground, ground is 0 voltage, right? 0. Then here we are having the ranges here up to that less than 2, it's showing 0. Then here above the above 2, it is showing now 1, right? So if you are having that voltage is 4 itself, it's showing now the logic is 1, right? So up to that 2.1 or 2.1 is 1. Then if you are having 1.9, it will come to 0. So that one is here. So if this voltage range is going to have as 1. So if you are having store, we are having that voltage 5 or 4, it is showing now that value 1, right? Desired data is placed in the bit line. Okay, the a stronger access transistor overcome the inverter stored state, right? Forcing the inverter to latch into a new data. So we are having storing the data, right? Where line is deactivated and the new data is stored. Okay. இதெல்லாம் not necessary. Just you write it that one, right? Next one is here we are having dynamic RAM. So the dynamic RAM circuit is, I told you that one through the capacitor. So this is a capacitor, right? Then we are having that word line is giving now this NMOS is activate. Then this activation is going to store the capacitance value. Right? Whenever we want to read, then it will activate. Then we are retrieving that information. The bit line is going to come, can store and retrieve that information. And also we are having one repressor circuit. Periodically it is repressing what is the value, right? The dynamic RAM is DRAM, dynamic random access memory. The basic memory cells consist of transistor and a capacitor. This is the transistor and this is the capacitor. The transistor act as a switch. It is act as a switch on and off, right? Then which the capacitor store the charge representing a bit of data. Charge is 1 bit. If no charge, then this is 0, right? When the transistor is turned on, it's either charge or discharge the capacitor representing 0 or 1. Charge is 1, discharge is 0 respectively, right? So this is the dynamic RAM, DRAM.